Hey guys, in this video we're going to talk about Rule 12 implication and Rule 13 contraposition. So these rules are in the second group of rules of deduction, and those are the rules of truth functional equivalences. So remember from your reading that two claims are truth functionally equivalent if and only if they have the same truth conditions. That means that two claims are only truth functionally equivalent if they're true at the same time and false at the same time. So two claims are truth functionally equivalent if and only if they have the same truth conditions. Again, that refers to the conditions under which the claims are true and the conditions under which they're false. So for example, we can take the two claims, Rebecca is alive and Rebecca is breathing. These are different claims, they're distinct, they say different things, and yet they're truth functionally equivalent because if one claim is true, then the other claim is necessarily true. And if one claim is false, then the other claim is necessarily false. I can't be alive and yet not breathing, and vice versa. So if it's the case that Rebecca is alive, then it has to be the case that Rebecca is breathing. And if it's the case that Rebecca is breathing, then it has to be the case that Rebecca is alive. Yet, if it's the case that Rebecca is not alive, then it would have to be the case that Rebecca is not breathing. And if Rebecca is not breathing, then it has to be the case that Rebecca is not alive. We're not talking about like what ifs, like in the zombie apocalypse or something. If we were, I'll just tell you now, I'm definitely not surviving a zombie apocalypse, so this is still going to be truth functionally equivalent. But let's just take this on its face. We know that if someone is alive, then they are also necessarily breathing. And if it's the case that someone is not alive, then they're not breathing, and vice versa. Okay, so these claims are truth functionally equivalent. They have the same truth conditions. They also would have the same truth tables. So two claims that are truth functionally equivalent have the same truth tables. That can help us understand a little bit more about what's happening in Rule 12 implication. So Rule 12 says, if P then Q, if and only if, remember, if and only if is a biconditional claim, and we write that as the arrow with two pointed sides. So we have if P then Q, if and only if, not P or Q. Okay, so why is this the case? In order to understand why the claim if P then Q is truth functionally equivalent to the claim not P or Q, let's get their truth tables up on the board. So the truth table for a conditional claim, we should all know this very well by now, is true. Okay, so first I wrote up our truth values for P and Q. So for P I have true, false, and then for Q I have true, true, false, false. And our truth table for the conditional itself is true, true, false, true. So our conditional claim is true in rows 1, 2, and 4. The only time that a conditional claim is false is when the antecedent is true, but the consequent is false. In this case, with P and Q, that means that this conditional is only false if P is true and Q is false. Okay, now let's get up the truth table for not P or Q. Since we're comparing the truth functional equivalence of these two claims, we need to make sure that we're giving the same values to P and to Q across the board. Okay, so we need to make sure that we're still saying that we're still writing up the truth values for P in the same order. We're going true, false, and that we're doing the same for Q, which is true, true, false, false. Okay, now remember, we're looking at not P. So instead of looking at the truth values for P, we want to flip them and look at the truth values for not P. So not P is false, true, false, true. Okay, so we're looking at the truth values for not P and Q. In row 1, in fact, I'm just going to erase these truth values for P so we don't get confused, but we see how we got these truth values. We went in the same order for P, then we flipped them because we're looking at the negation. Okay, so the disjunction claim, we know, will only be true if at least one of the disjuncts is true. So in row 1, is one of the disjuncts true? Yes. What about row 2? Yeah, in row 2 they're both true. What about row 3? Well, here in the claim not P or Q, row 3 gives us our situation in which both of the disjuncts are false. So in row 3, our disjunction is false. And then what about row 4? In row 4, at least one of the disjuncts is true, so the disjunction claim is true. Okay, so now we see here that our claims for if P then Q and our claim for not P or Q are truth functionally equivalent because they have the same truth table. All right, this means that if P then Q has the same truth conditions as not P or Q, or that if P then Q is true in all the situations that not P or Q is true in, and if P then Q is false in all the same conditions that not P or Q is false in, and vice versa. So in the situation in which, here I'm going to rewrite my truth values for P just to show you. So the situation in which P and Q are both true, both of these claims are true. In the situation in which P is false and Q is true, both of these claims are true. In the situation in which P is true and Q is false, both of these claims are false. And in the situation in which P is false and Q is false, both of these claims are true. They have the same truth conditions. Okay, so here we see that these two claims are truth functionally equivalent. They have the same truth tables. We can also see why these are truth functionally equivalent, even just by looking at the truth table for the conditional alone. So even if we didn't have this truth table, we can see that this claim is only true in the situation in which either P is false or Q is true. Either not P or Q. That gives us all the situations in which this claim is true. So if we just reason through this first truth table, we can also get the same conclusion. We can reach the same conclusion that these are truth functionally equivalent, that they're true in all the same conditions. Okay, so that's implication. Implication tells us that if P then Q is truth functionally equivalent to not P or Q. What about contraposition? Well, contraposition I put up here mostly because I wanted to point something out to you all. So it's true that we're going to have the same truth table here, and we can do that first. So we have true, true, false, true, right, for if P then Q. And then for not Q and P, remember, we're going to put in the same pattern for Q and P here, no matter where they are in this claim, because we're trying to compare the same variables. So we're saying that if this P is the same as this P, and this Q is the same as this Q. So even though Q is coming first, we're going to write T, T, F, F for Q, and even though in other situations we've written the antecedent as TF, TF, because again, it's the same Q that we have over here. We're doing TTFF, and then this P is TFTF. So this P is also going to be TFTF. Okay, so what about the values for not Q and not P? They're negation, so we just flip them. So not Q and not P, we're going to have false, false, true, true for not Q. We're going to have false, true, true for not P. These are the two that we're focusing on. Okay. So in this situation, which row in our truth table do we have a false conditional? It's still in the third row. It's still only false when the antecedent is true, but the consequent is false. That was always the case for any conditional. So they have the same truth table, TTFT, TTFT. They're truth functionally equivalent. What I wanted to point out, though, is that we don't need to do the truth tables to understand that. It's good practice to have, but we can look at this and just realize that it's really similar to modus tollens. Modus tollens tells us that if this is true, if that's true that if P then Q, then we know that if you don't have Q, then you don't have P. We also know that from our truth table for the conditional claim. If you don't have Q, then you don't have P. There's only one row on the truth table in which the conditional is true and the consequent is false, and that's when they're both false. So we can see in a number of ways why contraposition is a valid deduction. Okay, so hopefully that helps make sense of these two a little bit more and of truth functional equivalence. Two claims are truth functionally equivalent if and only if they have the same truth conditions. So the next rules of deduction and the last rules of deduction that we're going to have a video on are De Morgan's Laws, Rule 14. So make sure that you have your notes out and your book out for De Morgan's Laws.